Welcome back to the next episode of how Azure Information Protection works under the hood. Today we're gonna focus on how to get the required values from the registry and also from the profile folder in order to unprotect a read protected document. So let's start with first things we need to do. I prepared two folders which we require in order to get the corresponding files. So first I will get the MSIPP values from the registry. That's just a simple bash script which I used here, and then another bash script for getting the DP API values. But that didn't work quite correct, so I need to copy the local Microsoft MSIPC location and enter it here in the folder path, and then I can copy all the required values, the rights account certificate, CLC, and use license. So next I will start the DP API decryptor or data protection decryptor and unprotect the corresponding MSIPP-SK and MK value. As you remember from the last episode, we need to unprotect them with the help of the master key of the DP API, and therefore this data protection decryptor is necessary. So first of all, I will prepare the MK value and SK value here, so that we have a nice hex string which we can just enter, and we do it for the MK and SK value, and afterwards we can just open it with Notepad++ and copy the corresponding value into the data decryptor. Okay, so first of all, you need to set the decryption mode in the current process of the current user, and then you set that you want to decrypt a specific string and no optional entropy. And if you see this success button, you know, okay, that worked, and you can copy it to a text file, for example, in order to get to the hex values. I did it the manual way. You probably can just write a nice Python or Bash script which automate the whole process here. So now we have the value SK just before the RSA vault would come into place. So that's what we going in one of the next steps. First, we also going to unprotect the MK value here. So we need to copy this hex string, input into data protection decryptor, again with a specific string. Here you see it's really longer than the SK value, and yeah, now we also can copy this string into a new text file and use it later as an input for the whole unprotection process. So the DP API unprotected value here is right before we do the AES decryption. So now I will remove, with the help of Vim, the new lines and the spaces, white spaces. So this will take a little moment here. Like I said, you could probably just automate the whole process here. And what we're going to do next, we use the hooked IPsec proc DLL and use this one to reverse the whole RSA vault operation. So we do a RSA decryption and we'll see that the resulting value is a PKCS1 padded string with 48 bytes, which we then can use as an input to the SHA-256 function. So that's why we also need to prepare the SK value here as a hex string. And when we reverse the RSA vault operation here, and we can then use the corresponding AES key, so the 16 bytes from the SHA-256 value can we use as an input to export the whole RSA private and public key. So here I tried to reverse the hex string to a byte string, but this didn't work really. So give me a moment. So now I'm gonna use the hex editor. So that doesn't work either. So I use the prepared values here and open them. So the unprotected file I will now open with the hex editor. Yeah, okay. The copy process from the client side to the virtual machine did work, so I needed to open it in the Notepad++ in the virtual machine. And now I can save it in the folder where I have the executable, which will hook the IPsec proc DLL. So I prepared a bash script in order to do the whole decryption process. So I have to adapt this one. So here's the sk encrypted.dat file, and now I can adapt the input file name here, and the output is sk rsa decrypted dot file. And when I execute it, then we have the unencrypted RSA unencrypted value here, which we can now open in a hex editor. So I copied it. Okay, so again, hex editor, and if we open it in there, we see at the end that there is a 0002, which is the first 2 bytes of a PKCS1 padding, and then we will see later that there is a 0, which separates the padding from the corresponding 48 bytes. So here are 3 times 16 bytes, so 48 bytes, which we then can use in Notepad++. So this is the input for the SHA-256 algorithm. I save it as an SK hex input, I think, hash input, correct. So in that my script, my Python script can execute the SHA-256 operation on that one. So that's the reason why I input it here into that input folder. Now I just rename it to the correct value here, and we'll move all remaining files which are not necessary into the backup folder. So if something goes wrong, we have it for later use. And yeah, now we have the unprotected MK and SK value. And now we copy the values from the profile path into that input directory. Yeah, and now we're gonna find out which value we actually need. It's a lower one And here is the output folder and the input folder, process folder are both empty. And yeah, so we have all values inside of this folder, but we just need the use license for the correct Word document. So let's take a look another time into that folder, because I needed to check which value we really need. So that's the corresponding use license. We want to unprotect. We saw the difference in the date here. So the use license which we kept were newer. So that's just something I needed to know here in order to sort out the older use license. So I delete the unnecessary use license, and I think now, yeah, I'm gonna execute first time the prepare function in order to get all required enabling bits element, and afterwards I will execute for the first time the Python script in order to show you that parsing works correctly. And as we will see, we didn't prepare the encrypted document value. So in the input directory, we of course also need the document which is protected. So that's what I'm gonna do next. I will prepare the document in the following way. In the input folder, I create a new folder. So 1 second, I copied it into it. And now I create a new folder protected document. And there I can unzip the read protected document, because it's just a zip archive here. And now I have the encrypted package. And this encrypted package is symmetrically encrypted with an AES algorithm. So what I do next is I copy it as an encrypted underscore document. And now we have here the unencrypted RMS file. And yeah, that was the whole unencryption process. Everything else happened in the path.py file. And there is a decrypted document. I first will copy it as a decryption document manipulation, so I can later use it to manipulate and then reprotect it. And now I just renamed it to decrypted doc.docx, and now I can modify the previously protected document. You will find all this information and values inside the GitHub repository, so you can do it just on your own. On your PC, you just need Python3 here, and as you see, everything is just unprotected. And in the next video, we will see how to manipulate it manually or with the help of LibreOffice, and then reapply the protection. Thank you very much for your attention, and see you next time.